Let's suppose we had this equation, and someone told us this is an equation of a circle, and it happens to be in the general form. And they asked us to find what would be the center point and what would be the radius of this circle. Well, that we can determine when we have the equation in the standard form. So our task is to look at this equation in the general form and see if there is something we could do to put it into the standard form. And there actually is something we can do that will produce that standard form if we perform what is called completing the square on the x and the y variables that we have here in this equation. If you remember the completing the square process, it's actually one way that we can use to solve quadratic equations, but we're not going to be doing that here. We're not solving a quadratic equation. We're just using that same technique to put this equation into the standard form of a circle rather than the general form that it currently is. So what we're going to do first is we're going to collect the x terms together and the y terms together and put the constant that we have on the other side of the equation. And I left a little space because I'm going to be putting some terms in here. These will be the terms that will complete the square for each variable. And whether or not you remember completing the square, I'll go through the process for you. To find the value that we need to add here to create the perfect square trinomial, a trinomial whose factorization is the square of a single binomial, we take half of the coefficient of the first power term. Half of 2 is 1, and we square that. 1 squared is 1, and we add that to this side of the equation. Of course, if we add it to the left side of the equation, we'll have to add it to the right side of the equation. Do the same thing here for the y variable. Half of the coefficient of the first power term, half of 8 is 4. Square that. 4 squared is 16. That's what we will add here. And of course, we'll have to add it to the other side of the equation to keep our equation balanced. Now, this is a factorable trinomial that factors into x minus 1, the quantity squared. Plus, this is a factorable trinomial. It's a perfect square trinomial. It factors into y plus 4, the quantity squared. And 8 plus 1 is 9. 9 plus 16 is 25, which is 5 squared. And we have put this equation into the standard form of a circle. X minus h, so 1 is the x value of the center point of the circle, plus y minus k. Well, that would be y plus 4 is y minus negative 4. So negative 4 is the y value of the center point of our circle, equals r squared. 5 squared is 25. The radius of our circle is 5. And we've gone from the general form of the circle to the standard form of the circle using completing the square. That has enabled us to identify the center point and radius of our circle.